So in this video, we're going to review these questions on database management system and the dictionary. And just to get us started, we'll go through question 1, making a list of key functions for the database management system. Now you'll remember, if you look on its learning, you will see a set of notes on the database management system, this document here. Lots of information in here which is pertinent to what you're going to be talking about, but I just want to draw your attention to this picture here. First of all, we have various people talking to the database around the outside. The blue rectangle is the database management system, and down the bottom the yellow rectangle down here represents the files on the operating system that the database is stored in. So let's go back to our questions. Question 1, make a list of functions. Well, the first function we've got is it acts as a method of connecting programs to data, and one of the reasons we do this is because the database manages the storage of the data. So programs that don't need to know where the data is stored. You simply, as a programmer, send your data into the database management system. DBMS then goes ahead and stores that. It also maintains a record of what is in the database, where it is, and how it can be accessed. That's really quite important. So it knows where the data is stored, and that's maintained in the data dictionary. We're going to talk about that again later. It provides program data independence. Now this is a key concept. The idea is that our programs and our data are not inextricably linked. If you imagine writing a program which talks to a flat file, if you change the format of the records in the file, you have to change the data structures in the program because it's got to read data into data structures. And equally, if you want to change your data structures in your program, you've then got to go and change your data files. So you'd have to write another program to take data out in the old format, extract it, and then reload it into a new file in the new format, which is very unproductive maintenance. With a database that's completely removed, programs aren't affected by changes in data. It doesn't affect changes by programs. So a simple little thing like, for example, moving a data file from one disk unit to another disk unit will not affect the database very much at all. The data will just be unavailable while you're moving the file, but that's it. The programs won't be affected in any way at all. Whereas if you were to change the location of a file, your program wouldn't be able to open it if it was a conventional program. So what we're doing here is we're using abstraction. We're hiding the complexity of how the data is stored from the programs that access that data. So a big function of the database management system is controlling access to data. So it implements security mechanisms to ensure that people can only look at what they're allowed to look at. It can implement data validation rules, so we can put rules in the database. So for example, we could say this number has got to be between 0 and 100. This field is required, and so on. We can actually put those rules into the database, and then when you are accessing data, querying it, reading it, writing it, and so on, those rules will be imposed by the DBMS. It has a big job of maintaining consistency. So if you remember, consistency is making sure that all users see the data in exactly the same way. So one way we do this is we have various data integrity mechanisms in place. So one of the big ones of these is a transaction. Transaction is a group of functions that have to be, or operations that have to be carried out together. So it will implement DBMSs implement transaction systems. They'll implement validation rules, which we mentioned before, and they'll implement locking. And I'll put record in brackets because they will allow you to lock an individual record, so you can't have two people attempting to update the same piece of data simultaneously, but you can also lock at larger groups of data. For example, you can lock a table. You can actually lock the entire database if you're the DBA and stop anyone getting into it while you're doing maintenance work. They also implement data integrity mechanisms, providing mechanisms for recovery. So recovery is a big thing. That's one of the reasons we use databases. If you're halfway through storing data into a database and you pull the plug on the machine and it crashes, what we can do is we can turn the machine back on, restart your database up, and the database will recover, and it will make sure that data gets stored properly. It does it using all sorts of complicated mechanisms. You can kind of think of it as smoke and mirrors, but we can be pretty much 100% certain that if the database says I have saved that record, it is saved, and we're not going to lose it no matter what. Anyway, on to page 2. So question 2 here: how is the data dictionary updated by the DBA? Well, as a DBA, you don't update the data dictionary directly. You update it usually by specific SQL commands. So just to recap, the dictionary is a collection of metadata on the database. So metadata is data about data. So it tells you how your database is structured, how the data is stored, and so forth. It's updated by using specific SQL commands. So the commands we're interested with, we call these data description commands, or DDL. DDL commands, data description language commands. So this includes things like create table, create index, create user, create trigger, all the create commands. Alter, table, index, trigger, user, so on. Grant, revoke, and you can grant and revoke. This is where you give people the right to do something, or you remove the right to do something. And you've got really 4 operations you can use, which are select, insert, update, and delete. Read, create, change, and then remove on tables, and so on. So you can actually control access to individual tables using these commands. When you issue one of these commands, as I said, the database management system will ultimately update the dictionary, and as you run commands, as you insert data into your database, it also gets automatically, the dictionary also automatically gets updated, because the database management system will keep statistics on the data. So for example, when you add a record, it always maintains a count of the number of records in the table. If you've got an index, and the index allows duplicates, so this will be used to implement a secondary key. So if you imagine you put an index on the like the surname field in the database, every time you put an entry into that surname field, it will update a measure called the selectivity, and it will tell you the number of unique entries you've got. So if you've got an index which has 95% of the entries in it are unique, that's a good index to use for searching. If on the other hand you had, for example, a field in which you've maybe got one or two or three different values, then that would have very low selectivity, and therefore there's not a lot of point in using that index. So the idea is that we can use that data to kind of determine the best mechanisms that the DBMS to get at the data when people want to do a query of the data. So anyway, let's go and look at question 3 now. Question 3, what happens to the data dictionary when the database schema is being set up? So this is actually quite an interesting process. Just to remind you, a schema is, you can think of a schema is the content, is basically describes the things that are in the database. It doesn't describe the data, it describes the structures that are used to hold that data. And this information is maintained in the dictionary. And you can think of them at different levels. We have the conceptual schema. So this is entities and attributes. We store information about people. People have names and addresses and dates of birth and ages and stuff like that. So that's conceptual schema. We then have the logical schema, which is basically turns the concepts into things on a database. Basically, we're talking tables, indexes, and the reason, and relationships between the tables, which I didn't write in here. That is the thing that's of interest to a developer, because when you're writing your code, you're going to need to know what the tables look like, what they're called, and the fields in the table. You're going to want to know where the indexes are, so you can query them by the best methods, and you want to know about the relationships between the tables. And then we've got the physical schema, and really the only person that's really interested in this is the DBA, maybe your system support people, and that describes absolutely everything in the database. But it includes things like, for example, security information, physical storage information, and so on. So if you're the DBA, that's your primary interest. If you're a developer, logical schema is where it's at, and if you're kind of a designer, probably conceptual. Anyway, as it says here, as you add stuff to the database, the dictionary gets updated. So I've got an example here, which is when you issue a create table command, it will cause the dictionary to add. It will add the table name to the list of tables in your database. It will then go through that table. For each field in the table, it will then add the field name to the list of fields, along with the information about that field, data types, and so on, sizes, and what have you. If the definition of your create table has got any validation rules, for example, a data integrity rule, like a range check, it will add that to the table that holds information about range checks. You can create these things called triggers as well. So a trigger can, for example, fire when you delete a record. You might say, when I delete a record from this table, I want you to copy the old one and put it in an audit table, so we've got a kind of record of what's been changed. It would then add that code to the database. and it will also then update the statistics of the table and say basically that we haven't got any data in this table. And that's just a simple create table command. So there's quite a lot goes on when you enter commands into the system. Anyway, on to the next question. So how is the dictionary used when the user logs in to the database and accesses the table? So you've got to remember, if you just think of a system like Amazon right now. So we're on our Amazon web page and we've just seen that we want to buy, I don't know, a deluxe bag of some sort. So we type we go to the web page, we type our information, we press the search button. What's then going to happen is your web browser is going to just send that search to the database system, and the database system will then want a user ID and a password. Now, that information is probably you may well have entered that before, in which case it'll have been stashed away in a cookie on your computer, but now we're going to log on to the database so we can run the query. So first thing we do is we check the user ID against the list of users, make sure this person has a valid user account. If they do, we then check their password, and passwords are stored inside, or any decent database management system will store the passwords what's known as salted and hashed. In other words, they're stored securely. All you'll see in the data is actually just a great big long hexadecimal number. And you've got no way of reverse engineering that back to the password. Anyway, once you've got those, once you've checked that's a valid user, you'll either give them access or you'll issue some kind of error message accordingly. Anyway, we're now at the point where we can now run our query. So first of all, we scoop the table names out of the query. We're going to check them against the data dictionary and make sure we've got tables with those names. Secondly, we're going to go and check the fields in the query, make sure they're all valid. Do these fields exist in these tables? And the answer to that is simple yes or no. And if they are valid, what we'll then do is we'll then say, okay, is this user allowed to issue this command against that table? So first of all, do they have the right to issue that command? Let's say, for example, they're doing a select command. Have they got select privilege? And then secondly, do they have a right on that table? Because the only tables that you can implicitly query are the ones that you create yourself. So if they belong to someone else, which they should do if your database has been set up properly, you've got to make sure that this person has been given the right to query that table. And then, assuming you've done that, what we're then going to do is we're going to work out how to do the query. So we're going to check the dictionary for all the indexes, and we're then going to look at the statistics about the data we've got to this table. So we'll kind of look at the table and see, okay, we've got these indexes, they have these levels of selectivity, we've got this number of records in the underlying data structures and so on. Once we've done that, we're then going to go through a complicated mechanism to determine the best way to get at the data. Sometimes it's best to do a linear search through a table, even though we might have a couple of thousand records in it, because there are all sorts of things that will happen on the back end of the database that you don't really need to know about. That can make a linear search very, very fast if the system's been set up properly. Equally, you may decide you've got 3 indexes you could use. Well, which is the best index to use? You might use one index to search the table and another to actually help you sort the results. So there's all sorts of clever stuff goes on. If you take most database systems, they'll consider up to about 1,000 different access paths if they're available. Anyway, once that's all happened, the next phase is we need to find out where the data is, so we know how to get to it. It's just where is it? So we've got to go and get the operating system files the data lives in. And again, a table might actually be split across many, many, many operating system files. So we've got to know the names of those files, and then we've got to know where in the file the data is, because sometimes our database may actually be talking directly to the file and bypassing the operating system. We can do this with things called raw files. So we're going to find out where the data is stored, and then once we've done that, we can then start running the query and generating the data or the data set that we're going to return back to the user. So there's a lot goes on when you just type when you do something like go into Amazon and say, I want to have a look at bags that look like that, please. Anyway, next up, how's the dictionary used when the user runs an SQL command? We've covered this already, really. The first thing we do is we check that the user has authorization to issue that command. For example, there's a privilege called drop user, which allows you to remove users from databases. Not many people will have authorization to issue the drop user command. So does this user have drop user privilege? yes, no. Once we've done that, we're then going to look at the access right on the object. So if we're talking about tables, does the user have a right to access that table? Can they run that command on that table? And the answer to those questions is either yes they do or no they don't. So we'll either let the command run, or alternatively we will give some kind of error message. Anyway, that's the questions on the database management system. If you want to find out more about this, I would encourage you to head over to It's Learning and go and read these notes on the DBMS, which you will find here. There's lots and lots and lots of lovely information in here, which you need to avail yourself of, and make some notes on it, have a good read, and I'm sure you'll find it most educational. Thank you.